Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor Space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenter. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will also be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. This session will run approximately 1 hour with questions throughout, and I'll now turn it over to our speaker for introductions.
Hi everyone, I'm Shreya. Thanks so much, Irina, for starting us off. I'm so excited to talk to you all today. And just to quickly introduce myself, I'm a PM on the Azure Functions team. And within Functions, I focus on the Python developer experience, as well as extensions with functions. So today I'm going to be talking to you all specifically about serverless, Azure Functions, and most specifically, the newly released model for Python. This is the V2 programming model that we've just released yesterday into preview, and I'm going to give a quick demo and show you all about what it's all about. And on this slide, I also have my contact information listed, so please feel free to connect with me on LinkedIn or on Twitter. With that, let's get started. So as I had mentioned, today I'll do a short overview of serverless technologies, go into Azure Functions, and then describe the V2 programming model for functions using Python. And at the end, I'll also do a demo of how you can get started today. So with that, serverless computing is what enables developers to build applications faster and eliminates the need for them to manage any infrastructure. So a few notes about serverless. First, as the name suggests, serverless has a full abstraction of servers. It allows developers to just focus on their code and forget any distractions around server management, capacity planning, or even availability. Next, there's instant event-driven scalability provided by serverless. So application components can react to events and triggers almost in real time with almost no scalability issues. Compute resources are actually used as needed. And that brings me to the last point, pay per use. With serverless, you actually end up only paying for what you use. Billing is typically calculated on the number of function calls, code execution time, and memory used, and so on. Some additional benefits of serverless is that it allows you to solve business problems and not technology problems. So just focusing all that energy into writing the code, developing the business logic. Also, in terms of efficiency, there's a low barrier of entry and friction to write set up serverless applications. So you can prototype and ship apps in a matter of weeks or even days. In fact, with the demo, we'll see how quick it really is to get started. And also, there's a lot of flexibility when you get started, and also when you're ready to scale. You really have this ability to experiment and go at the pace that works for you. Awesome. So now I'll give an example of serverless technology, which is Azure Functions. Azure Functions is a serverless solution that allows you to write less code, maintain less infrastructure, and ultimately save on costs. Essentially, instead of worrying about deploying and maintaining servers, this cloud infrastructure will provide all the up-to-date resources that you need to keep your application running. A few notes about Azure Functions. So Azure Functions, like mentioned, is a serverless technology, and it's an event-driven service that provides compute on demand and enables code and logic to run when triggered by events. Functions is also a service as a service, so you can set up and just be ready to go in a few minutes. Like I said, demo is coming up. As I mentioned, Functions also allows you to focus on deploying that code, and the rest is just taken care of for you. Also, there's a lot of out-of-the-box technology associated with Functions when it comes to observability and monitoring. You can also trigger on many different event sources, and this includes queues, Event Hub, IoT Hub, Cosmos DB, and many, many more. So lots of built-in connection with other technologies when you use Functions as well. And as a note, Functions is built for developers and for enterprises. I also like to call out that Azure Functions is an open source project. So you can actually check out the code at this link over here. So you might kind of be wondering, what does a function include? So I'm going to go over the terms triggers and bindings as an overview to what the programming model looks like when we're trying to create a function. So as you can see here in this diagram, a trigger is what starts the function and has it run. As an example of this, if I had a queue and each time a message is added to the queue, I'd perhaps want some logic to run. And in this case, we'd be using a queue trigger since we're triggering the function by that event. Next, we also have input bindings. Input bindings are generally for when we're adding data into the function or adding something into the function that's not related to the trigger. So for instance, if I wanted to correlate whatever I'm getting from my trigger with a line item in a database, then I could use that database as an input binding for my function. Lastly, we have the output binding. And the output binding is where we put information as the function processes the information we've provided it. So if I wanted to maybe update a database, maybe I wanted to add a record or a log to a sheet, I could do that through an output binding. And the last one that I forgot to mention, but is kind of the most important, is this white section here, which is your code. That's the logic that you've written, and that's going to actually determine what's happening here. Awesome. So now I'm just going to go over some common scenarios when it comes to using functions. So this first example is the automation of scheduled tasks. Uh, Over here, we see that there's a database that we want to deduplicate for entries every 15 minutes. And this is so we don't send multiple communications to the same customers. So as you can see, we start off with this database that might have duplicates, and we run a function, perhaps on a timer, on a schedule, and clean out that database and update it such that there are no duplicates anymore. Awesome. For the next slide, I'm going to be talking about real-time stream processing, which is another common scenario. So in this case, we have a lot of telemetry that's coming from a cloud app. And the solution that we want is to visualize this data in a dashboard. So using function apps, and we actually are able to go ahead and process this data such that it can be used for visualizations. In near real time, we can ingest the data, process the data, send it to a database, and have it ready to use for visualizations. The next example I'm going to go over is IoT-connected backends. So in this example here, we have connected IoT devices that are producing data, and functions will actually detect anomalous data and triggers a message to service department when a repair is required. So this is another app. So these are just like a few applications of functions that we can see being used when we like look into the real world. Awesome. So now I'm going to go into the V2 programming model. So this new model actually enhances the way that Python developers create functions. And if you're familiar with functions and already use it, I want to call out that this model just changes the way that we interact with and develop functions, but the underlying process of debugging, monitoring, and deployment, all of that will remain the same. If you're not familiar with functions, then using this V2 programming model will hopefully give you an experience that is more idiomatic to a Python developer's experience. So you might be wondering, why did we create this model? So this model is actually the first of a functions-wide initiative to make the development experience more idiomatic to the language itself and more similar to what a native developer in that language may expect. So Python will be the first language to release in Azure Functions this new model as part of this initiative. Some of the reasons that we created this model is because functions is really popular with Python developers. We do see a lot of usage from our customers. And through conducting a lot of research and speaking to Python developers, we found that there is quite a big learning curve when it comes to understanding the current V1 model. And because we wanted to get rid of this learning curve and make it more Pythonic, we decided to come up with this new model and a few different changes. We ultimately just decided that we'd want to meet customers, meet developers where they're at, and improve this function's development experience overall. This new model is going to be more natural to Python customers. It's going to be more natural to Flask and other frameworks that are familiar to customers as well. The same concepts that I described in the earlier slide of triggers and bindings, all of that will stay the same. It's just the way that the code is written and developed will be more familiar to Python developers. Awesome. So the first thing I want to go over is the folder structure. So when you go ahead and create a function application, the first thing you'll see are all these different folders. And this is if you create in VS Code. And so what do these files mean? So the most important one is going to be function underscore app.py. And this actually contains all of the functions that you have in your application. So this is kind of where all your code is going. Next, we also have the host.json file, and this contains more configuration details at an app level. We also have the local settings.json, and this contains app settings and also connection strings when you're running locally. So if you're connecting to a database or wherever you may be connecting to a storage account, if you're running locally, you can store the connection string within the file local settings.json. We also have the requirements.txt file, and this includes Python packages for publishing to Azure. Now we also have many optional files, one of which is called blueprints.py. So it can actually be named anything. It doesn't have to be called blueprints.py. It could be called users or tests. It's essentially a place where you can add additional functions that belong in your function app. Just like with a blueprint, you would actually reference this within the function app.py, but you can store it in a separate file for logical grouping and also for extensibility. So just to go a little bit deeper into the programming model, looking over here, we can see that the triggers and bindings are now represented as decorators. So if you're a previous user of Azure Functions, then you might be familiar with the file function.json when developing in Python. We replaced that file now with these decorators that actually incorporate the same content, but in the decorator format, which is more idiomatic. You can also see that the IntelliSense here is very helpful in allowing you to develop quickly and intuitively as well. I also want to add, if you look up here, the import Azure Functions as func. So when you import here, this kind of gives you all the usability aspects of functions, such as being able to define triggers and bindings in this simpler way. So we are just trying to abstract some of the things that you'd have to go into more detail in order to develop otherwise, and making it as simple as possible when you do use functions. Okay, and now to talk more about blueprints, which I did gloss over in that earlier slide. As I had mentioned, blueprints are optional, and it is something that you can use when you're developing function apps. A blueprint is essentially a new class, and it's instantiated to register functions outside of the core function application. The functions, though, aren't registered they're not directly indexed by the function runtime, so they're registered in blueprint instances only. And to get these blueprint indexes, it's important that the function app needs to register the functions from the blueprint instances. So essentially, in function app.py, we do need to account for the blueprints still. Blueprints are great because they allow developers to break up the function app into modular components, and they ultimately enable developers to define the functions in multiple files. And they also allow us to divide different components as well. They also provide extensible public function app interfaces, so you can build and reuse your own APIs. One of my favorite features of the new model is how discoverable the documentation is within the IDE itself. So if you're using VS Code, as you can see here, Once you open the command palette and go to create a new function, you'll actually be able to view the function within the code, within the sample code itself. So you could select any trigger that you like, and you have the option to preview the template, and this markdown file will open for you, which has a snippet of the code that you're going to use. This way, you can learn about it, have that deeper dive before you commit to pasting that code in your file or actually creating the function app and having to maybe go back. I love this feature. It just feels like it makes it so much easier when you're going in and trying to create a function for the first time. You're really able to learn about what all there is before you commit to it. So next, I'm going to be doing a few different demos. The first demo is just going to be of a simple HTTP function running locally. So if you were to get started today, I'm going to share the links in the chat once we wrap up. If you were able to start today, then this is kind of what your experience would be like with running the function with the V2 programming model. So as you can see here, we start off by creating a new project using the command palette. And since the project is local, we'll go ahead and select an empty folder to store the project. Then we're going to opt to use the Python programming model v2, and we'll select our runtime. And I've chosen to open it in the current window just because my window was empty. And now you'll see this familiar folder structure that I shared in the previous file. This is the function app.py file. And when we create it in VS Code, we currently just have a trigger that's set for you, but it's commented out. So if you would like to run this HTTP trigger, you can just uncomment out the code. And as you might have seen, I quickly went over to the file local settings.json, and this is to add a storage connection string. So there's two options. You can either input a storage connection string to your local settings if you're planning on using any storage account associated with the app, or you can run a storage emulator like Azure. So once we've uncommented the code and added the storage account string, we can go ahead and run our app. Awesome. So it worked properly and we were able to get this URL. And upon going to the URL, we can see that the HTTP trigger did execute successfully. And then you can see I parsed a name through it as well. I parsed my name Shreya, and it was also able to respond and capture that name. So I really want to hone in on how easy it is to get started. If you're interested in doing this, all you need is the Azure Functions extension. Well, I guess all you need is to follow the quick start that we have for you that I'll provide the link of in the chat. I think Irina might have already provided it as well. And then you can just go ahead and get started. And just by creating the function app itself, you already have this boilerplate code that will work and kind of demonstrate to you how we can just use HTTP function within the new model. The next demo I have for you all is related to the Flask application. So with Flask, sorry. I think I didn't go to the next slide, sorry. Okay, yes, so this is the next demo that I have for you. Essentially, if you have any Python code already that uses an existing web framework like ASCII or WSGI, you can actually just bring that code straight into a function. So this demo is of a Flask application that I have. It's a simple Hello World application, and I'm just going to demonstrate how easy it is to wrap and run in functions using this new model. So as you can see here, this is a simple application. It's just hello world. And I've already had it running, but the only thing I did is I moved the sample Flask app inside the same repository as my function app.py. And then I'm just going to go ahead and import this application into my function app.py code. And then using the WSGI function app wrapper, I'm able to pass in these arguments and run the code. The other thing to note is we want to add the Flask version to the requirements.txt file as well to make sure that can be incorporated. We also have to add to the host.json file as well to make sure that, sorry, it's gotta, let me just navigate here. Yes, so we want to go to the host.json file and ensure that we can incorporate this addition as well. It's quick. Of the extension application as well. And then once we make these changes, we're able to run the app. And as you'll see here shortly, we will hopefully get a Hello World application running. That's a Flask app, but with the Whiskey wrapper. So essentially, I just want to really highlight how easy it can be when you're able to just take existing code, existing Flask app, and just wrap it and bring it over to functions. Awesome. With that, I would be happy to take more questions. Looks like I finished a little bit earlier than anticipated, but to sum up, I'd really love if you all would try out the V2 programming model for Python. And if you have any feedback, please feel free to ping me or to add the issue to our GitHub repository. We'd love to hear from you, and we're really trying to make this experience as amazing for Python developers as we can. So would love any feedback and would love for you to try it out. Irina, are you there?
Yes. Do you want me to read the question to you?
Oh, yes.
Or you can use StreamYard because we have about 2.
Okay, awesome. So I see the first question as from Michael, which versions of a Python runtime are supported? 3.11. So it's a great question. We're currently supporting up to from 3.7 to 3.9, and we're anticipating support of 3.10 by the end of this month, so very, very soon. So keep your eyes open for an announcement where we support 3.10, and we're now working on supporting 3.11 as well, but we do not currently support it.
Looks like there's another question from Aaron.
Yeah, awesome. Do you have any YouTube channel or playlist recommendations? Yeah, definitely. So I love watching Azure Fridays. So I would recommend looking into Azure Fridays as a channel to follow as well.
While we wait for more questions to get added into the chat, I'm just going to quickly hop on and say, if you have any feedback, we'd love to hear what you have to say. I have added the Reactor survey link to the screen as well as in the chat. And for this specific event, it's 17459. We'll give it a few more minutes on if anyone else has any other questions.
Awesome. Thank you so much, Irina.
I don't see any more questions coming in. Do you have any other details you want to talk about or end the session from here?
Yeah, I think the event resources page will be really helpful. So I know you put it in the chat, Irina, but it's aka.ms/Python programming model. So if you have a chance, please go ahead and use that link. And there's all the resources, including a quick start to get you started on using the new model, as well as a developer reference guide as well. That goes into a lot of the same details I went in today. So yeah, with that, I think that's all I had. Thank you so much for your time.
Thank you, everyone. Until next time.